So when a metal reacts with a non-metal, we get an ionic bond. But how about when two non-metals react together? Well, this is what we call a covalent bond. So covalent bonds often form molecules. These are a collection of two or more atoms held together by chemical bonds. An example of a molecule would be water, so H2O, and these are the covalent bonds in between. And as I said, the whole structure is known as a molecule. Alright, so let's focus on ammonia or NH3 molecules. Well, what's important to note is the covalent bonds, so these lines in between the molecule. So let's focus on ammonia or NH3 molecules. Well, what's important to note is the covalent bonds in here are very strong, so require a lot of energy to break. But between the molecules, we have these intermolecular forces. And these are very weak and don't require a lot of heat energy to break and separate them. And that's what gives a low melting and boiling points to ammonia. So let's try and visualize the covalent bonds with dot and cross diagrams. So for this example, we are going to pick hydrogen, which is one electron on its outer shell. And we are going to pick chlorine, which is in group 7, so has 7 electrons on its outer shell. So here are our atoms. We should know that hydrogen can only hold a total of 2 electrons on its outer shell, so it can only receive one more electron. And chlorine, as we said, has 7 electrons in its outer shell and can hold a maximum of 8 electrons in its outer shell, so it can receive one more electron over here. So what they can do is they can share their electrons. So now the hydrogen electron is now being shared with the chlorine electron, and what this means is now chlorine has a full 8 electrons in its outer shell, so it's stable. Likewise, this unpaired electron in the chlorine atom has now been shared with the hydrogen atom, so now hydrogen has 2 electrons in its outer shell, so it is also stable. The nuclei at the centre of each atom are very strongly attracted to the shared pair of electrons, and that's what gives covalent bonds such high strength. But atoms can actually form multiple covalent bonds, not just one, as we've seen in the example before. So looking at the periodic table at the non-metals, we can easily work out how many bonds an atom can make. So group 4 elements have 4 electrons on its outer shell. They can hold a maximum of 8 electrons. So that means they can form 4 covalent bonds as they have 4 unpaired electrons. Likewise, elements in group 5 have 5 electrons in their outer shell. They can hold a maximum of 8, so they can form 3 covalent bonds. Group 6 have 6 electrons in their outer shell. They can hold a maximum of 8, so they can form 2 covalent bonds. Group 7 elements have 7 electrons in their outer shell, so they can also hold 1 more electron in their outer shell, so it can form 1 more covalent bond. Noble gases in group 0 don't form any covalent bonds, and as we saw, hydrogen can form 1 covalent bond. So let's look at ammonia or NH3. Nitrogen is in group 5, so it can form 3 covalent bonds, and each hydrogen atom, as mentioned earlier, can form 1 covalent bond each. So here is a dot and cross diagram. We can see that nitrogen, which is represented by the circles, the electrons are represented by the circles. We said it had 5 electrons in its outer shell and has 3 unpaired electrons. And each hydrogen atom can receive 1 of these electrons, as we can see here, and they are sharing the electrons. So now each hydrogen atom has 2 electrons, i.e. its full outer shell, so they're all stable. And because the nitrogen is sharing each hydrogen's electrons, that means nitrogen has received 3 electrons, so now has a total of 8 electrons in its outer shell, i.e. a full outer shell, so it is also stable. So to complicate things further, some molecules contain double covalent bonds. So let's look at the famous gas CO2, or carbon dioxide. Well, carbon is in group 4, so has 4 electrons on its outer shell, so it can receive 4 more electrons, so it can form 4 covalent bonds. Oxygen is in group 6, so 6 electrons on its outer shell. It can hold 8, so it can form 2 covalent bonds. So hopefully we can appreciate that carbon requires 4 more electrons to be stable and have a full outer shell, and each oxygen atom requires 2 more electrons to have a full outer shell and be stable. Well, to achieve this, each atom can share 2 electrons instead. So oxygen shares a pair of its electrons from the carbon atom, and that gives oxygen a full outer shell. See, we have 1, 2, 3, 4, 5, 6, 7, 8. So it's a full outer shell. Same with the other oxygen atom. Likewise, carbon can receive a pair of electrons from each oxygen atom, as we can see here. And what that means now is the carbon atom also has 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons in its outer shell, so it has a full outer shell and both atoms are stable. This can be represented as oxygen, and a double bond represented by an equal sign. Carbon double bonded to another atom of oxygen. Okay?